Hey everybody, it's Dr. J, and today we are talking about solubility rules. Let's talk about chemistry. Let's talk about solubility rules. Okay, so there are going to be certain basically ions, right? That either you're going to have a soluble compound or an insoluble compound, depending on what you have, right? So let's just start out with all of our soluble compounds. If you got a compound that contains an alkali metal, I had to get deep with you because first off, everybody should know what an alkali metal is. If you don't know, that's that very first column, right? That very first column on your periodic table. So if you got a compound that contains an alkali metal, right, ion or ammonium ion, it's always going to be soluble, straight up. All right, there's no exceptions to this rule. All right, if you have a compound that contains, once again, lithium, sodium, potassium, you know, that whole row, alkali metals, it is soluble. Next up, if you have nitrates, NO3, bicarbonates, HCl3, or chlorates, right, ClO3 here. If you have any one of these polyatomic ions in your compound, this is a soluble compound. All right, if it contains any one of those, it will be soluble when you throw it in, right, into some water. It's going to be a soluble compound. It will dissolve. That's what we're talking about with these solubility rules. So basically, you have to know, right? First off, you got to know some of these elements, but then you also have to know your polyatomic ions. That's the reason why I said, y'all got to know those polyatomic ions. It's coming back. It's coming back. All right, now let's look down here. Halide. All right, if you got that last row there, chlorine, right? The row that starts with the chlorine. All right, if you have these halides at all in your compound, they will be soluble. They will always be soluble. Now, there are some exceptions in this case to this particular rule. So if you have a compound, but say you have a halide and silver, right? Or mercury, or right lead, Pb. If you got any one of these with this halide, then it's insoluble. It will not dissolve once we put that into our liquid, right? It's not going to dissolve. It's going to stay as a solid. If we look at our sulfates, SO4, right? Y'all got to know those polyatomic ions. If you got a sulfate, this will normally be a soluble compound. However, there are some exceptions to the rule. For instance, if you got silver, calcium, strontium, barium, mercury, or lead, right? If you have a sulfate with any one of these elements, right, as a compound, then it's going to be insoluble. Insoluble. So it will not dissolve. Will not dissolve. Now, on the other end, let's look at insoluble compounds, right? So these compounds are normally going to be insoluble. So basically, when I'm talking about insoluble compounds, they're not going to dissolve when we throw it into our liquid. So carbonates, right? Carbonates are insoluble compounds. Phosphates, PO4, right? Phosphates, not phosphite. Phosphate, PO4, right? Insoluble. Chromate, right? CrO4 here, and then sulfides. If you have any one of these ions in your compounds, it will be insoluble. Okay. Now, on the flip side, let's say that you have one of these, right? Let's say you got carbonate and it's combined with the alkali metal. Well, right, in this case, alkali metal is always going to be soluble, right? So look at this list here. Notice how this is the very first one, right? Because this rule really to me is number one over everything else, right? If you got an alkali metal or if it's ammonium, it's always going to be soluble. It's always going to be soluble, okay? And also, another compound that's normally insoluble is hydroxide, OH, right? Know those polyatomic ions. All right, so it's normally going to be insoluble. However, if you have an alkali metal or barium, you combine that with barium, you're going to have a soluble exception. All right, so soluble or insoluble. Let's look at the very first one. Agbr. Before we even go any further, right? Y'all should know this name. What's that name? What's my name? Say it. What is it? Silver bromide. All right, it's silver bromide. Now, here's another question to you. Is this a molecular compound or ionic compound? I see a metal and I got a non-metal. It's going to be a ionic compound, right? It's an ionic compound. So, if we understand what ionic compounds, then we must understand that we have ions in our compound, right? When it's going to be dissolved. That's a huge hit, man. That's game right there. Take that. Run with that. So, silver bromide. Here are some rules. This is where solubility comes in place, all right? So even if you're thinking, oh, it's an ionic compound, we got to check our solubility rules because everybody's different. So this is what I was talking about. I got this compound here, silver bromide. How are we going to look at this? Well, I see that, bromine is a halide, so it normally should be soluble, right? And we talked about the whole ionic compound thing. We got ions here. However, there are exceptions to the rule. If you have our bromine with one of these metals, in this case silver, then this will be a insoluble compound. So if you said this is insoluble, give yourself a hand clap, all right? What about B? So B, right, we got copper chloride here. Copper chloride. Okay, y'all know that, right? So copper, I know is a metal. We got a non-metal over here, chlorine, ionic compound. So most of these are ionic compounds, in case you didn't know. Let's look to our rules. Let's look to our rules here. So chlorine, another halide, all right, Cl. Now, normally it's insoluble, but it's with copper. Is this part of the exceptions? Ag, Hg, Pb? No, right? So, because it's not an exception, this is going to be a soluble compound. All right, if you got B right, go ahead and give yourself a round of applause. What they say. Took it back to school with you. Okay. Now let's look at another one. Lead chloride, right? Pb. Now chlorine. Once again, another halide. Now, is this going to be soluble or insoluble? Let's look at it. Cl normally is going to be soluble. However, if you combine with one of these metals, Ag, Hg, Pb, it then becomes insoluble. And is it combined with one of these three metals? Yes. Pb. So because it's PbCl, this is a insoluble compound. All right? Not going to be dissolved. If you got that one right, go ahead, clap it up. And then let's look at the last one, D. So we got D here, sodium hydroxide. Now, sodium and then hydroxide. Hydroxides are normally insoluble, right? But of course, we always got to look at our rules. Does it contain an alkali metal? Is sodium an alkali metal? Yes, it is. So because it contains an alkali metal, therefore, even though it's combined with the hydroxide, it will be soluble. Okay, so sodium hydroxide is actually a soluble compound. If you got that one right, go ahead and give yourself a clap here, give yourself a clap there. Right? And this is how we're doing solubility rules.